Hi, this is the walkthrough for the lockdown knowledge boost, and it's higher number 3. Question number 1. I'm given the volume of a cone, pi r squared h over 3, and I'm given the radius, so the volume is pi times 10 squared times h over 3, and I'll just write that a little bit more neatly as 100 pi h over 3. We know that the volume of a prism is the area of one end multiplied by the length, and the area is a triangle, so that's a half times base times height, and that's multiplied by 20. Half of 10 is 5, 5 nines are 45, 45 times 20 is 900 centimetres cubed. Because the volumes are the same, I can set them equal to each other. 900 is 100. I just realised a mistake. 100 pi h over 3. I didn't write my pi there. I'll write it now. Divide both sides by 100. Multiply both sides by 3. 27 equals pi times h. So h is 27 over pi, and I'm not asked for, it's not specified how I should round it, in which case I'm going to go for 2dp 8.59 centimetres to 2 decimal places. Question 2. I've got a circle and a triangle that's on the diameter. First thing I know then is that that's a right angle. Any triangle on a diameter is a right angle triangle. I've also been given that angle there, that angle there, 180, because angles on adjacent angles on a straight line. 180 minus 61 is 119. So that angle there is 119 degrees, which means I can now work out the area in the small triangle, sorry, the angle in the small triangle by doing 180, subtract 34, take away 119, 180, take away 34, take away 119, is 27. So this angle here is 27 degrees, and of course x is 90 minus 27, which is 63 degrees. Similar shapes. The volume scale factor is big volume over little volume, which is 8. We also need to remember that the volume scale factor is the cube of the linear scale factor, so if I cube root 8, then I get the linear scale factor. So the linear scale factor is 2, which means I do 20 times by 2, and that's 40 centimetres, which is y. Question 4. So I recognise that the perimeter of my sector is made up of my arc length, which is a portion of the whole circumference, and 2 radii. The arc length is saying if I get my circumference, divide it by 360 and times it by pi, that's the curved arc length. So I'm going to say that I know the whole circumference. Circumference, remember, is 2 pi r, so it's 30 pi. I'm going to work in pi, substitute right at the end. This is clearly going to be a calculator question. So the perimeter is theta divided by 360 times by 30 pi plus 2 15s, and that's equal to what I'm given which is 36 centimetres. So I need to solve this equation for theta. Well, I'm going to simplify this fraction first of all. Remember, I could have written a fraction like that. I could have extended the vinculum to have 30 pi in the numerator. So divide top and bottom by 30, I get 12 pi times by theta, and at the same time I'm going to subtract 30 from both sides, so that theta is 6 over 12 pi. That's not right at all, is it? Let's try that again. Divide top and bottom by 30, the 12 ends up on the bottom, doesn't it? So theta pi divided by 12, that's better. And take away the 30 from both sides, gives me 6. So theta pi, multiply both sides by 12, 72. Theta is 72 over pi. Now in a non-calculator paper they might want you to leave it like that. If it were a calculator question, I'm just typing in 72 divided by pi. It says one decimal place, 22.9 degrees. Okay, number 5. Oh, that was number 4. Right, number 5. This is a right-angled triangle, so I know I'm looking at Pythagoras or trigonometry. There's an angle involved, so it must be trigonometry. So the first thing I do is I label my sides. Well, opposite my angle is my opposite. Oh, that pen's not working. Let's try blue. Yeah. Right, the H, the hypotenuse, and I know it's trigonometry, so it's SOHCAHTOA because it's a right-angled triangle. O and H, that's sine. So the first equation I'm going to write is sine of the angle is opposite divided by hypotenuse. I don't want the sine of the angle, I want the angle, so I can do the inverse sine, which is inverse sine, to both sides of my equation and type exactly that into my calculator. Inverse sine 42 over 48. Notice I haven't simplified 42 over 48. I don't. That's unnecessary because I'm using my calculator anyway. And I'm not told how to round, so because of that I'm going to go for 2dp and state that I've rounded to 2dp. Okay, number 6. Well, there's angles and sides involved. It's not a right angle triangle, so it's not SOHCAHTOA. It's a cosine rule or a sine rule question. I need the perimeter. That means I need all 3 sides. Well, I can certainly work out the third angle. 180 minus 63 minus 65 is 52. I'm given that that side's 6 centimetres, and I'm going to call that A and that B. I'm going to use the sine rule. I recognise it's the sine rule because I've got a side opposite it's an angle, and I'm trying to find another side opposite the angle. I'm going to use the sine rule to find both sides separately, then add them all together. So A over sine 52 equals 6 over sine 65. So A is 6 over sine 65 times by sine 52. Now I'm thinking ahead a little bit. I want my answer to be correct to 2 decimal places, so I'm going to work to 3 decimal places. 6 over sine 65 multiplied by sine 52. 5.217. Now I'm going to find B. B over sine 63 is also equal to 6 over sine 65, so B equals 6 over sine 65 times by sine 63. 5.899 to 3dp. The perimeter then is just the sum of all 3 sides, and remember, since I've rounded to 3dp, I know that my answer is going to be accurate to 2dp. 6 add 5.217 add 5.899 is 17.12 centimeters to do to 2 dp. So there's an exam technique point there. If I know my final answer needs to be accurate to 2 dp, then I work to 3 dp. Okay, question 7. Class A. If I know how many people there are and I know the mean, then I know the total. Class B. I know how many people there are and I know the mean, which means I know the total. So the overall mean then must be the sum of the two totals divided by how many pupils there are altogether. And it says this time 1 dp, so I'm typing in exactly that on my calculator. One, 2, 6 times 16, add 1, 3, 14 divided by 30, and the mean then is 119.9 centimeters to 1 dp. Okay, comparing box plots. Remember, we compare the median and the interquartile range. So let's have a look. The median for the children, 8 minutes. The median for the adults, 15 minutes. So comparison number 1. The median for the children is greater than that for the adults, and you have to say what that means. This means the average time for adults is longer or greater or slower than that for children. You'd get marks to say adults complete the puzzle more slowly than children on average. You have to say that you understand the median means the average time. The interquartile range for children goes from 5 up to 11, 12, 13. Oh, 11, 12. Nearly read the scale wrongly. 5 up to 12. So that's 7. The interquartile range for adults goes from 12 to 20. So that's 8. So for adults it's very slightly more. So the interquartile range for adults is 8, is greater than that for children, which is 7. This means the data for adults, now I can say it's more spread out or slightly more spread out or less consistent, and that's what I'm going with. The data for adults is less consistent than for children. So you compare the median, say what it means, compare the interquartile range, say what it means. If you're quoting the numbers, they need to be correct, so do double check that you've read the scale correctly. I nearly didn't. Fortunately, I fixed it before I made that error. Okay, number 9 is about remembering that on a histogram, the area of each bar is the frequency. So the width of this first bar is 2, the height is 17.5, So the frequency is 35. Second bar, 2 times 15, frequency is 30. Third bar, the width is 3, the height is 10, frequency is 30. Fourth bar, the width is 5, height is 5, frequency is 25. What fraction of buses were less than 3 minutes late? Well, first of all, I need to know how many people there were altogether, and then how many buses would sit underneath the 3-minute mark. Now, we assume that these 30 buses are equally spread. So I've got 15 in each half. So less than 3 minutes, what fraction was less than 3 minutes late? Yeah, less than 3 minutes is 35 at 15. So less than 3 minutes, 35 add 15, and that's out of a total of 35 add 30 add 30 add 25. That's the population in each of the boxes. I'll type exactly that in, let the calculator simplify it for me. 5 over 12. Okay, so 5/12 of the buses were less than 3 minutes late. Part B, bus company offers a full refund if the bus is more than 10 minutes late. So again, I need to think about, out of the 25 in this box, how many were more than 10 minutes. And we can do this visually because I can split this box into 5 equal sections. I've just used the squares on the graph, so whatever's convenient works here, which means, of course, each of those boxes is 5. What percentage of passengers will receive a full refund? Well, that's over 10 minutes, so it's 10 out of, I can't remember what the total was before, 35, 65, 95, 120. So that's a 12. Oh, sorry, it was a percentage, doesn't it? Well, I might as well use my calculator to do that. Give your answer to 2 decimal places. Nearly didn't times by 100. 8.33% to 2 dp. Okay, question 10. 5 lemon and 4 strawberry takes out a sweet. Now, because it's put back in, this is a more straightforward question. Lemon, strawberry, lemon, strawberry, lemon, strawberry. So the probability of getting a lemon, 5 out of 9, which means strawberry must be 4 out of 9. And because the sweet's put back in, it doesn't change. It's always critical to check whether we're looking at with or without replacement. 5 ninths and 4 ninths. Okay, so that's part A done. The probability of 2 lemon, the probability of lemon, lemon, remember we go along the route, and every time I see a probability, I multiply. So it's 5 ninths times by 5 ninths. Now, that's 25 over 81. I'm not going to try to simplify it. I'm not told to simplify it. If I simplify wrongly, I risk losing the mark. So 25 over 81. The probability of one of each flavour. One of each flavour, one of each. Well, that's the probability of lemon strawberry or strawberry lemon. So lemon strawberry, 5 ninths times 4 ninths. Or is add in probability, and of course strawberry lemon 4 ninths times 5 ninths. So that's 20 over 81 plus 20 over 81, 40 over 81. I'm not even going to consider simplifying. The probability of no lemon sweets. No lemon. So I could do the probability of, well, no lemon, in fact, is just the probability of strawberry, isn't it? So I'll just do that. 4 ninths times by 4 ninths. Just check that Yeah, 4/9 times 4/9. 16 over 81. Okay. Yeah, we are good. That's your lot. See you next time. Bye-bye.